I can't believe that. Thank you guys all so much for coming to watch me talk. I have a tendency to speak very quickly, and I am acutely aware that I'm in a room full of people who may not all be native English speakers, and my talk is very long. So instead of blasting through everything at light speed, I'm probably just going to end up skipping a couple of slides, so just stick with me. And I'm going to put the slides up at some point, and if you have any questions or if you want a copy of the slide, any point, then just fire me a DM on Twitter. So I'm going to go ahead and get started. Thanks again for coming. Thank you guys all. Thanks to Microsoft for doing this. It's incredible. Let's get moving. So this talk is called Staying Ahead of Internet Background Exploitation. I'm going to talk about what that means, and I'm going to talk a little bit about kind of basically how we can think about this problem and how we've been thinking about it. So I'm Andrew Morris. I'm the founder and CEO at GrayNoise. I started GrayNoise about 5 years ago, and I'm like relentlessly obsessed with internet background noise and what we're increasingly referring to as internet background exploitation or mass exploitation. I'm really, really excited to be here. This is my Twitter and my email account. You can email me anytime. I try to be as responsive as humanly possible. So this is a really quick agenda of what I'm going to go over. Basically, what's the problem? Internet mass exploitation of given vulnerabilities. What's the solution to the problem, or GrayNoise and how we're thinking about it, and what are some of the really interesting things that we've observed in building and operating GrayNoise over a period of time. And then I'm going to kind of sum it all up and give you guys a couple of fun things that you can play with for the next time everything gets really haywire. And so with that, the problem is basically really bad vulnerabilities keep being identified and disclosed in really common internet-facing software products, and everyone freaks out about it, and it is something that used to happen every now and then, but it really does feel like it's been happening more and more often. And so it feels like kind of every other month or a really bad vulnerability is announced, and then everyone gets really scared, and there's a proof of concept, and it starts getting exploited at scale, and nobody knows what to do. So I've got a stat here that's basically taken from an organization that's older than 5 years old that has basically indicated, look, a lot of breaches that are happening actually start with initial access vectors of like scan and exploit, right? Actually, one of the things that I really loved from that last talk that we just heard is not every vulnerability that is really, really bad that's exploited on people's networks is a 0-day. And in fact, the vast majority are not. Old vulnerabilities are really effective as well. And I'm going to talk about that here today as well. So basically, this is a map of celebrity vulnerabilities and kind of on a timeline. So you don't even really have to be an expert data scientist to look at this and say like, okay, there's a lot of them, right? There are a lot of them, and it seems like they are happening more frequently. Now, on one hand, it could just be that maybe we're, marketing vulnerabilities a little bit too much, which is possible. But on another hand, it's also possible that the bad vulnerabilities that keep coming out, like the shell shocks, the heartbleeds, the log4js, things like that, it really is possible that these things are just happening more frequently, and we're trying to kind of figure out why that might be and what we can do about it and why this is a hard problem. So my theory of why we're here, and this is a very complex problem, so I don't want to grossly oversimplify it, but the shortest, most succinct answer that I can give on why I think that we're here is a combination of advances in vulnerability research, right? People are we, the security community, and bad guys, are getting better at basically developing exploits for software and developing exploits for the right software and for software that is widely deployed, et cetera. And software security isn't necessarily catching up at the same rate, but kind of more to the point, the attack surface is increasing drastically. We're using more software in more computers, in more places, and vulnerability research is also getting more advanced as time goes by. The second thing is this idea of mass scanning or internet mass scanning is evolving, right? So that means that the internet is basically it feels like it's shrinking, right? It's really easy to mass scan the entire internet very, very quickly to find whether or not a vulnerability in a piece of software is running on a host, or rather to find all of the hosts on the internet that a vulnerability exists on. And it's not brand new, it's just we're all kind of learning this together, and the cat's out of the bag, so everyone kind of knows that this is the case now. So because of reasons like the tooling getting better, ZMAP and masscan, those things have not been around for that long. I mean, it's relatively recent. IP addresses that people are scanning the internet from are actually, they're recyclable. You can, as soon as you burn an IP that you've scanned the internet with, you can just get another one, instantly from 1,000 different hosting providers, right? And the internet is literally just faster. It's faster than it used to be. So you can blast more packets out onto the internet. So a combination of both of these two things, vulnerability research evolving, mass scan technology evolving, a combination of those two different things yields, well, mass exploitation is now possible, right? So back in the day, and again, this is grossly oversimplified, this is kind of the way that a lot of people used to think about hacking, right? Okay, so I'm a bad guy. I want to break into a network. So this is just a kind of anecdote. This is the way that we teach these things, or we talk about these things. As a bad guy, I identify my target. I'm going to scan them. I'm going to enumerate the software that's running on their networks. I'm going to enumerate the different vulnerabilities. I'm going to find or identify the vulnerabilities on my target. I'm going to exploit those vulnerabilities. I'm going to operate. I'm going to do whatever it is that I'm here to do, move from system to system, find data, blow stuff up, whatever it is that I want to do. And then, I'm done. I'm good, right? And so now we're starting to see this kind of new sort of weird thing start to happen, that it's different. Instead of targeting one organization and then doing everything that you can to go after that, bad guys are increasingly starting with a vulnerability. So they start with a vulnerability, and then they say, let me scan the entire internet now. I'm going to scan the whole internet to find how many vulnerable systems there are out there, right? So now we have like a smaller pool. Now I'm going to compromise as many hosts as I possibly can. I don't care where they are, right? It doesn't matter to me. I'll figure that out later. I want to compromise as many systems as I possibly can. And then I'm going to deconflict my accesses. And what I mean by that is I'm basically just going to figure out, like, okay, how many computers have I compromised? Where are they? What networks are they in? Do I actually care about any of them? Maybe I've got 10 compromised hosts in this network over here, but I don't care about that network. And I've got one really interesting one right here, so that's great. I'm gonna look at this one. And then I'm either gonna, like, I don't wanna say trade, but I'm gonna sell, I'm going to hand off, I'm going to give those accesses to someone else, right? And then I'm in a good place, right? And so this causes what I'm referring to here as like threat model creep, right? When you're trying to build a threat model, and again, this is grossly oversimplified, but you basically just say an actor does an action to an asset, resulting in an outcome because of whatever their motivation is, right? So now you have to think about it a little bit differently, because now the asset is like the whole internet, right? It's the entire internet. And that kind of changes things for us a little bit. That means that we have to change the way that we think. That means that we kind of all have to care about things that happen on the entire internet, and there are people that are trying to find vulnerabilities in software to just compromise as many hosts as humanly possible, and they don't necessarily care where they are. You can kind of still get owned, right? And this is something that we're learning and relearning kind of over and over and over again through. So I'm going to introduce this concept called internet background noise. If you have ever talked to me for any more than like 10 seconds, I've probably started talking to you about internet background noise. Basically, the internet's really, really, really noisy, okay? So if you plug like your laptop directly into the wall and you have no router or firewall in between you and the internet, and you turn on Wireshark, you're going to see people scanning you, even though nobody even knows who you are, where anything about you. That's because the internet is really noisy. There's a lot of internet background that is hitting everybody all the time. So internet background noise is basically caused it's caused by a number of different things. It's caused by people that are credential stuffing, bad guys doing a bunch of bad stuff on as many hosts as possible. It's caused by good guys who are scanning the internet for totally legitimate and good reasons, like Google crawling the internet for web content, Shodan and Census and other different security companies that are scanning the internet looking for command and control servers or trying to find vulnerabilities in their customers' hosts, like attack surface monitoring products, things like that, right? But at the end of the day, the internet is just really noisy. What I've got on the stage behind me, this is actually an animated GIF of 1 year's worth of actual internet background noise that we've collected at GrayNoise, and each pixel is an area of the internet, and the top right is the reserved IP space, so that's why it's completely blank, it's completely empty, there are no routable IPs up there. And somewhere around like here is Census, and somewhere over there is Shodan. And somewhere around this whole thing is a lot of worms and a lot of credential stuffers and bad guys doing bad stuff, right? So the internet's just really noisy. It's really, really noisy, and it makes this difficult, right? So again, why is the internet so noisy? Well, this is just a list of some of the reasons why the internet is so noisy. And again, none of these are bad things. This is a list of organizations that scan the internet. It's also a list of organizations that scan the internet that GrayNoise actually has tags for that we monitor and that we've attributed to their infrastructure. So, I mean, this is almost 100 right here. And this is just a small fraction of a representation of all internet background noise, right? So this is very, 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 very common. There are probably another 5 to 10 of these companies that get started and that start scanning the internet pretty much every year. So the internet's really just kind of getting noisier and noisier and noisier. So just to drive this point home a little bit more, we lifted from a paper that was written in 2004, an academic paper, an academic computer science paper, basically something along the lines of, hey, look, with one IP address looking at the internet, if someone's scanning the internet really fast, like sending 10 packets every second or scanning 10 addresses every second, then, which is, ludicrous, it will take you, 13 years. It'll take someone 13 years for them to see that, for someone else to observe someone who is scanning the internet at 10 hosts per second or 10 packets per second. Now, this was lifted from a paper that was written in 2004, okay? Now, in 2013, again, this is 10 years ago, MassScan was released, and it can scan the entire internet in less than 5 minutes, blasting out 10 million packets per second. So we can already see that, scanning the internet's gotten a lot easier, and it's happening much more quickly, and it's much noisier than we kind of expected that it was going to be. So I am going to actually go into a lot of these different vulnerabilities and case studies like this, but at the end of the day, a lot of the time, as we're thinking about mass exploitation, one of the first things that you're really going to think about is okay, well, I'm a security person, maybe I'm a defender, or maybe I am a systems administrator, and a new vulnerability has been disclosed, or I get a bulletin, or I'm talking to a friend, and I find out about some vulnerability. This is kind of a little flowchart that we put together, very basic flowchart of like, will a vulnerability be mass exploited across the internet, kind of like log4j or something like that? Is this thing going to be mass exploited based on some set of criteria? Ask yourself, is the vulnerability remotely exploitable? Yes. Is there a public POC? If there's a public POC, that's actually one of the #1 drivers that will lead to mass exploitation of a vulnerability, because bad guys are actually kind of lazy. They don't really want to do any work. So if someone else has already written the exploit, they're really, really happy with that, right? So this is one of the biggest drivers that leads to mass exploitation. Is the software typically running on the internet, right? If it's like a service that's like running on a deeply buried inside of people's networks, then no one's probably going to mass exploit the given vulnerability out on the entirety of the internet. Is the software widely deployed, et cetera. How does this kind of show up for different people? How does this pain manifest? And who does it manifest to? Well, for network defenders, they're exhausted because this happens all the time, constantly, and it's really frustrating. And security defenders are basically always in a state of reacting to the last really bad vulnerability. Cybersecurity vendors kind of feel like idiots when this kind of thing happens, because their customers are asking them, hey, what can you tell me about this vulnerability? Do we care? Who's exploiting it? Where's it coming from, right? And security vendors are like, I have no idea. Like, I don't have insight into this. And so they feel kind of stupid, right? Software vendors feel bad because they're like, oh God, we're in the news and no one's gonna trust our software and this totally sucks. And hosting providers are just like, please stop compromising devices from our networks, or vice versa. Please stop owning our customers' devices. This is really bad and it's not good. And I'm tired of taking calls from the FBI, and I'm tired of responding to abuse complaint reports. So the problem is hard for a lot of different reasons, but it boils down to, in our opinion, more or less, people don't really trust data well enough to want to make block decisions when things like this are happening. They don't want to cut their users off, and a lot of people's data kind of sucks. It's really hard to have something useful to say when someone is exploiting a vulnerability across the entire internet that just was disclosed like a day ago. It's really hard to kind of like get something out at scale, like very, very quickly, that's useful to people. You don't want to cause your customers to lose revenue. You don't want to cause anyone to lose money, and there's just a ton of different scale issues. So like, when a really big bad vulnerability comes out the next time, like, how can we really think about it? Well, actually, as it turns out, and I'm going to talk about this more, WhackaMole style, short-term blocking of very small lists of IP addresses very quickly actually works a lot better than you would think that it does. Believe it or not. It sounds dumb, it's pretty ugly and gross, but the results kind of speak for themselves, so I'm excited to share those with you guys. When the next log4j happens, if anyone in here was one of the people who was scanning the internet, exploiting or like looking for log4j while log4j was happening, don't do that again, please. I know you mean well, but it's not helping. It actually makes things a lot more difficult for defenders. So please, we need more collective defense, more information sharing if you have good data. The problem is most people don't have good data. And just, if you're a defender, just assume that pretty much anything that's sitting on your perimeter on very little notice will become very, very, very vulnerable, and threat model or architect around that, right? But the long and the short is, really bad vulnerabilities are coming out every other month, and we can't stop the vulnerabilities from existing. Unfortunately, there's nothing we can do about that. So we have to start thinking about what we're gonna do when it happens next, right? So now I'm gonna talk a little bit about GrayNoise, right? Our solution to the problem. And just to be very, very clear, everything that I'm going to talk about today is like a free thing that you can use right now. I'm not here to push any products on anybody. This is all free stuff. So if what I'm saying is interesting, you can literally pull your laptop out right now and you can browse to everything that I'm doing. You don't have to give us a dime. So our solution to the problem, basically, before I go into the way that we're doing it. The prior work that I want to talk about is, again, there are a few different organizations that are tracking exploitation of vulnerabilities in the wild across the internet. GrayNoise is one of them, but Rapid7's Attacker KB is fantastic. They track over 600 different CVEs at scale, and the United States CISA, which the previous speakers were talking about as well. They track which vulnerabilities are being exploited in the wild and what you can do about it, et cetera. And so we're not the only people who are doing this. There are actually more than one organizations, and there's a ton others that aren't on this list in particular, but we just wanted to capture the ones that we have some statistics on, just to make sure that that's really clear. So I don't know the absolute ultimate solution to this problem, but one way to solve the problem is let's deploy a gigantic network of collector sensors or honeypots onto the internet, so that when bad guys start exploiting things at scale, we can know about it really quickly, right? And we know where the attacks are coming from, so we can do something about it. Let's listen to all of this internet background mass exploitation that's happening from a bunch of different places, and let's be able to make our sensors look like whatever they have to look like, right? Let's make them be able to look like an Apache server, make them look like an Exchange server, make them look like whatever we want, right? Then let's signature or fingerprint every single exploit attempt that we see at scale, put them into a catalog, right, that we're able to kind of track, and let's temporarily block bad guys from people's networks before the attack lands on the customer or the user's perimeter, right? That's what we're going to try to do. That's what we do at GrayNoise, and I'm going to talk about kind of the results that we've seen from doing this and some of the interesting takeaways that we've had. Really quick GrayNoise origin story. I started the company almost 5 years ago. It all kind of got started. I started building the system a while ago. It basically got started because I gave a talk at a conference when I was somehow, when I looked like that. And I gave a talk at a conference about like this distributed honeypot system that I built in 2013. And basically, it turned out that the problem that I was trying to solve was like really relevant to some really interesting people. And so they had a bunch of money, and they said, "Hey, we want to know who's scanning. We want to know who's scanning the internet for XYZ different reason. And if you can figure out everyone who's scanning the internet all the time, then that would be really useful." And so I basically became like really, really, really obsessed with this problem, and I've been kind of working on solving it for quite a while. But the long and the short of what GrayNoise is we operate thousands and thousands of sensors across the internet. It's centrally managed. We are distributed geographically, so that means we have sensors in many, many different countries. We are geographically, we are diverse in a provider and a data center perspective, so we have sensors that are located in pretty much every provider that you could possibly think of. They pretend to be whatever we want them to pretend to be, so they can look like anything we want them to look like. They're programmable. And the hosts are actually ephemeral, which means, you know, it's like Snapchat. It's there and then it's gone, and no one cares, right? So the hosts go up, they come down, and it doesn't matter. That's how it's supposed to be. Honestly, the reason that the hosts are ephemeral is because you have to assume that people are going to figure out where they are, and so you want to switch them up real quick, right? So nobody knows where they are. We process billions of events every day, and that amount increases over time as we've been adding more hosts and as the internet has actually been getting noisier. We tag the data, which means we actually write signatures on the exploit that our sensors are seeing, and we support a number of different use cases, but I'm not going to talk about most of those today. I'm only going to talk about one in particular, opportunistic compromise, mass exploitation. And we give away a bunch of free stuff, like a massive amount of free stuff. So check out our website, like go and look at it, and it, you know, there's, you probably find some free stuff for you. You never have to talk to us, it's great. I am probably going to breeze through a lot of the challenges that we've experienced just because I don't think I'm going to have the time to get into as much detail with these as I'd like to. But at a high level, there are many challenges. These are some of them. And the first one is like, it's hard to do this fast. It's really hard to do this fast at scale. it's hard to stay in front of exploits, especially when you don't really know what's coming or what software is vulnerable or something like that. You only have a few minutes to go from a bad thing happening to one of your sensors to making a block decision for somebody else, because that's about how long it takes for someone to scan the entire internet. So you want to try to block things before they land on your customers, right? It is not enough to be correct, and it is not enough to be fast. You have to be correct and fast. And so that's one of the reasons why this is really challenging. If you're building a system like this, or if you're thinking about this as well, another one of the problems that you're into is actually selecting hosting providers, like where do you put the sensors. The really big cloud hosting providers are actually like super easy. You can put stuff into AWS, Azure, DigitalOcean, Google Cloud. Those are all pretty straightforward. It starts to get really weird when you run out of major cloud hosting providers and you have to start putting things in like really esoteric kind of back alley discount, Joe's discount hosting provider or whatever, especially because a lot of the time those providers are using websites that maybe aren't English or Hebrew. So you kind of have to use a lot of Google Translate to even figure out how to spin up servers in their website. Automation maturity is basically just referring to, like how good are their APIs? Do they have APIs? If you have to go to a website and like click on stuff to make the servers go up, it's not going to work. So you're going to need to have a good set of APIs. Cost, everything's expensive, et cetera. So basically, like AWS is really good for kind of like back-end processing. I understand I'm at a Microsoft conference right now. API deployment is basically something that is challenging because you need to make sure that your everything is basically rock solid with CI and things like that. It's really expensive to deploy a bunch of sensors at scale, so you have to make sure that you're only deploying like the teeny tiniest ones that you possibly can to save as much money as humanly possible, et cetera. Just the logistics of paying all of these different providers is really tricky. It's actually a lot harder than some of the technical challenges that you run into. Some of the providers that you're going to be looking at require prepayment, or they don't accept your currency or something like that. Sometimes they're going to require a local phone number to a certain region. You're going to end up with a lot of complexity if you try to do like a one-to-many mapping with IP addresses to hosts. It's a nightmare, and so it's something that you're going to have to think about if you try to solve this. We've certainly had to think about that quite a lot. Basically, like, fortunately, we're in a place now where infrastructure as code maturity has really grown a lot. So you're going to run into some automation challenges. We certainly run into a lot of these. And then again, when you're deploying tons and tons and tons of sensors out onto the internet across the globe from a bunch of different places, you're going to run into a lot of like latency issues while you're doing this stuff like across the entire planet. If you're deploying 1,000 sensors from our office to China, then it's probably you're going to run into some latency issues that are solvable if you have a complex network of jump hosts. But if you don't have a complex network of jump hosts, then it's going to be challenging, right? Especially because you have to keep these things going up and going down all the time. And then finally, and this is one of the things that I'm the most excited about, geographical challenges, right? Internet background noise and mass exploitation are really, really weird and chaotic. And one of the things that's really interesting about internet background noise and mass exploitation is internet background noise is actually different sometimes from country to country, believe it or not. So that means that internet background noise in the United States is not the same as internet background noise in China. So if you're trying to protect customers in China, then you need to have sensors in China. And so you have to put a lot of effort and energy into like really deploying sensors to the right places into as many countries as humanly possible. And it's really hard to find hosting providers in some areas of the world. But once you get it right, and once you've deployed to a certain critical mass of geographic providers or a bunch of countries, you can do really cool stuff, like really interesting stuff. Like, for example, you can really easily tell like, what's every IP address that's only scanning Israel's IP space? No other country. all of Israel's IP space, but they're never touching anything else, right? So we did it. And I put up a link right here, and you can just download this file right now. This is every single IP address that is only scanning Israel's IP space for the last month. And you can download this for free. It's unauthenticated. You can take a picture just in case you don't get it, but the file's not going to go down. It's going to stay up. So if you miss it, then just send me a DM or ask somebody else for it. But it's really cool. And so this is some of the stuff that you can do once you have actually properly deployed your sensors to as many places as humanly possible. But again, you're going to run into a ton of different challenges. We've had a lot of people freeze our accounts, think that we're committing fraud, think that we're doing crimes, because we have hosts that are going up and down all the time. And so people think that we're doing some kind of scam stuff, but we're not. And the last point on here, challenges that you're going to run into in operating a network kind of like GrayNoise, is people who are scanning the internet or crawling the internet are going to lie to you. They're not going to always tell you the truth. So sometimes, we've got two really easy examples right here. There was somebody that was crawling the internet for ENV files, so ENV files or sensitive environment configuration files and SSH keys, and they were advertising themselves as Census, using their same user agent and RDNS that says, hey, I'm Census, but it was definitely not Census. And so fortunately, we were like, hey, we know that this is BS, so we tweeted about it. And then this Googlebot pretender, this is like a classic. People love scanning the internet, saying that they're Googlebot from like networks that Google would never scan the internet from. And so we see this a lot as well. We actually tag this in GrayNoise right now. So this is something that I've always found to be really amusing. Most of the time when people scan the internet trying to look like someone else, you just make yourself stick out even more to the people who have been doing it for a while. So that's certainly something that I think is really interesting. So with that, I am going to spend probably the remainder of this talk just talking about things that we've actually seen or observed with GrayNoise and kind of some of the interesting things that we've seen, as well as finally where I think we're going to go or what we're going to do about it. So I would like to really briefly cover a couple of these case studies. These are big name brand branded celebrity vulnerabilities that have been exploited at scale. And I'm going to try to just briefly touch on each one of these four, but like I mentioned before, we're seeing kind of one of these every other month. So if I miss any of these, then don't worry, give it another month or two, because we'll see more. I'm going to first talk about the Apache patch reversal vulnerability here briefly. So really quickly, this was a really interesting vulnerability in that this happened around October of this past year. Basically, one of the things that was interesting about this vulnerability is that it was patched internally, right? It was patched in Apache's GitHub, or in their Git source code. So someone was aware of the vulnerability. Then GrayNoise starts to see people exploiting this vulnerability, right? The vulnerability hasn't even been announced yet or disclosed yet. Then a proof of concept is released, and then, like magic, mass exploitation skyrockets for this vulnerability, right? So this is just a really quick breakdown of the timeline. But this one was really interesting because we actually we see this stuff all the time. We see new vulnerabilities come out. We write a signature for it. We make sure that our sensors look like whatever. We catch up to it. We send out our tags, and the rest is gravy. This one was really interesting because the exploitation started happening before the vulnerability was even announced. So that was really bizarre. But basically, this was one of the ones that I thought was kind of one of the more interesting vulnerabilities that I've seen. So I thought that was worth starting with. The oh my god vulnerability was also really interesting. This one I'm just going to tell like a funny little story. It wasn't nearly as interesting from a timing perspective. It was just kind of like a fun thing that happened. So this vulnerability is disclosed, and GrayNoise starts seeing exploitation of the vulnerability. And the first thing that happened is that we started, we wrote our signature for it, we wrote our tag, and then we started to see exploitation of it from a number of different IPs, including some security companies, which we thought was really interesting. So one of our researchers was just tweeting about the vulnerability, and this guy is the CEO of a security company who scans the internet. So he was like, hey, just so you guys know, he told us, we're not actually checking for this vulnerability. So please untag us from this, right? And so there's just a small kind of interaction, and our researcher says, hey, look, we've actually been seeing it for this time. This is what we've seen. Like, let's chat about this really quickly. And the company replied to us again, like, no, like we're checking for this thing, but we're not exploiting this vulnerability. And we talked to this team back and forth a couple of times, and it actually turned out that they were actually checking for that vulnerability, like months and months and months before anyone even knew that it existed. And so it was really interesting, and we were able to kind of derive this just from looking at the data, and our research team was like really, really on top of it, and it was really, really exciting. So it was pretty cool. But it was like accidental exploitation of an interesting vulnerability, like 4 months before anyone even knew that it was a thing. So we thought that was pretty interesting, and I wanted to highlight that. The confluence vulnerability that came out last year was really interesting for a few different reasons. It followed the kind of similar pattern that we've seen before. Vulnerability is announced, everybody freaks out, exploitation starts to happen, and one of the things that was interesting about this vulnerability was Rob Graham, who wrote MassScan. He wrote, if we live in a time in MassScan where if you haven't patched in the time in between a vulnerability coming out and 1 hour, then you're going to be owned. And a lot of people actually kind of like yelled at Rob for that. They were like, hey, you're being kind of crazy. But it was true. It was actually literally true. Within several hours of this particular vulnerability coming out, we started to see exploitation of this vulnerability because somebody had opened up a pull request to Nuclei, to Project Discovery, and it became zero cost, virtually zero cost to exploit this vulnerability at scale, like within hours. And everything was lined up this way. So it was really, really interesting. So this one I found to be particularly interesting because most of the time when security people say that everything is really bad and on fire, they're just kind of making stuff up to sell products to you. But this time it was actually literally true. And so that really like blew my mind, and I thought that was really, really interesting. And then finally, of course, I'm going to briefly talk about Log4j. The really funny thing about Log4j was that the very first big wave of exploitation that hit everybody on the internet here came from exclusively Tor exit nodes, which we thought was really fascinating because from our perspective, we know how expensive it can be to scan the internet. And when I say expensive, I mean complexity, bandwidth, effort, et cetera. So for someone to do that through Tor was really interesting. Not necessarily the scanning portion, but the exploitation portion at scale to virtually the entire internet. And this first exploit payload for Log4j, exploiting it at scale through Tor, wasn't particularly sophisticated in the payload itself. It was kind of interesting because of the way that they did it. But it attempted to exploit this vulnerability through Tor, which we found interesting. At the beginning, almost all of the exploitation that was happening was just people cramming the Log4j string into as many different fields as possible and then saying like, okay, let's see what happens. Like, let's just see if we get any shells. And that continued for the first few days. And then actually over the weekend, we started to see product-specific payloads that started to come out where security researchers, vulnerability researchers, et cetera, had actually started developing custom payloads for different products that were running Java so that they knew that they would get successful exploitation. And so this one was really, really interesting. The last reason why Log4j was so particularly interesting is because you can't really check the existence of this vulnerability without exploiting it. You can't really scan for it. So what's interesting is like at GrayNoise, we know that, look, checking for the existence of a vulnerability on the internet and exploiting the vulnerability are not the same thing. Scanning for a vulnerability and exploiting a vulnerability are not the same thing, except sometimes they are the same thing, right? And this was one of those times that it was the same thing, and that makes life really kind of complicated. And so the takeaway here that I have from this is, look, sometimes security researchers and security companies who are exploiting vulns at scale, they have great intentions, but it does actually just make things much more difficult for everybody because nobody really knows that you have good intention, and it's very difficult to differentiate you from the other 1,000 bad guys who are doing that all the time. So it's less helpful than you might think. So this is just a really quick snapshot of kind of some of the stats that we're seeing of the amount of unique IP addresses that are always either scanning the internet or attempting to exploit hosts at scale. This is on a monthly basis, so you can see that we'll go through, we've seen 1 million IP addresses this month, 1 million IP addresses this month, and this is interesting because this basically tells us a couple of different things, but one of the different things that it tells us that's really interesting is that there's this concept of a noise floor, right? The noise floor is basically this kind of, it never really goes below like a couple 100,000 IP addresses. There's always at least a couple 100,000 IP addresses scanning the internet, like all the time. So we actually spent a little bit of time trying to quantify what is the noise floor actually, like how much overlap is there, et cetera. And where we ended up is that this shook out really, really interestingly, but basically on a daily basis, 25% of the IP addresses that are scanning the internet or exploiting hosts on the internet today are brand new. And 75% of them are the same from yesterday. And then the next day, it's the same thing. You lose another 25%, you have a new 25%, and then 75% are the same ones from the day before. And so with this logic, you can kind of figure out that like after 4 days, the entire list of all internet background noise is effectively useless. Right? So you kind of have to be doing this all the time. The data is just very, very rapid. You can't think about it the same way that you would think about maybe threat intelligence or something like that, which might be useful for a long time. The raw data under the hood is very, very rapid, and it changes very quickly. Right? So again, the long and the short is that about 75% of every IP address that's scanning the internet or exploiting hosts out on the internet is the same from yesterday, whereas 25% are brand new. Every day, day over day over day, which is interesting. And then finally, I just want to talk about some like other weird stuff that we've seen at GrayNoise. We've been seeing a lot of these spoofed noise storms, which is when someone is blasting the internet, either some of it or all of it, with spoofed packets from other places that they never received the responses to. And we're actually seeing a really, really, really bad noise storm right now, specifically in Ukraine. So someone is actually blasting IP addresses in Ukraine with spoofed packets that maybe have something interesting in them, maybe they don't. It's unclear why this is happening. By the way, this first one here, spoofed noise storms, if anybody here at all has seen this same thing or experienced this, then please come and talk to me at any point. This is like my white whale. Like, I've been chasing after this problem for so long and I have no idea why it's happening. The first time we saw this particular phenomenon at GrayNoise, it happened to be the same day that the United States military killed Soleimani, the Iranian general. So it was really interesting that it started right then, and then periodically we see it go down and then come back up. I'm not willing to say that it's always the same people, because you just really have no idea, but for some reason, every couple of days or weeks for the last kind of 2 years, we will periodically see someone blasting the internet with spoofed packets that are never, with responses that are never received, and we haven't really figured out exactly why, but it keeps happening and it's really interesting. Bad guys like acting like security companies who scan the internet. They masquerade. I talked about this. One of the really interesting things that you're going to see is that as we deploy lots of sensors to different hosting providers in different countries, we notice patterns where sometimes people are actually blocking things upstream of us, and we notice that, right? Because like, oh, hey, why didn't we get this packet that every other host got? It's because your hosting provider blocks that traffic, or perhaps the country blocks that traffic on the way in, which is possible, right? And Bad guys think that they're really sneaky, of course. Security researchers and security companies think that they're really sneaky too. So they like to scan the internet and do it from one place and advertise who they are, and then also do it from somewhere else but not tell you that it's them, and it all looks the same when you're actually looking at the data at scale, so they're not really as sneaky as they think they are. And then just a funny thing that we noticed last year was somebody was blasting printers across the world with anti-capitalist messaging, specifically to try to print documents out of receipt printers in restaurants and in hotels and in things like that literally had like anti-capitalist messaging of like quit your job, form a union, you're worth more than this. And it was really interesting for us. So we actually reported it, and a couple of people actually wrote about it. But I remember when we saw this, we were thinking like, is this really happening right now? And we got on Reddit and on Twitter, and there were like a lot of people that were at work like, yo, can someone help me fix my printer? It just keeps printing these things out. And like just uploading, tweeting pictures of it, which we thought was really interesting. But we saw 5 or 6 different versions of the message, and they all had some different kind of like, you're a wage slave, you need go home, form a union right now. These are your workers' rights, like things like that. It was really, really interesting. So it was just a fun thing that we saw at the end of the year last year. So anyways, like kind of to wrap all this stuff up, more basically, the thing that we can actually do about this is kind of a whack-a-mole style system where, again, there's nothing we can do about the exploits really. They're going to happen, and that's just kind of how it is. But the whack-a-mole method of blocking things prior to them getting to you actually shows a surprising amount of promise. So I'm going to just talk to you guys really quickly about an experiment that we run at GrayNoise pretty often. So our hypothesis is basically, if you block pretty much everyone who's scanning and crawling the internet, whether they're good guys or bad guys, like whatever, if you just block it all with really, really short, narrow windows all the time, it will take longer for a device to get compromised. That's it, right? It will make the problem suck less. So to kind of test this, we stand up 2 identical hosts on the internet that are both really, really vulnerable, okay? And it's actual software, they're really running all this stuff. And we just basically say, all right, extremely vulnerable host right here, good luck, you're naked, and that's the end of that. And then another host right here where it's actually blocking all of the IP addresses that are scanning and crawling the internet, exploiting the internet, et cetera. And we measure the time that it takes for them to get compromised. And then we do it again, and then we do it again, and then we do it again. And what we found is that with at least like easily guessable credentials, it takes 20 minutes for a host that's on the internet to get compromised, on average. Now, we used easily guessable credentials because it's common on the internet, and it's also kind of the same thing as when a really bad vulnerability has just come out, at least from the defender's perspective, right? When we blocked the traffic, it took the same very, 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 very vulnerable host 4 days to get compromised. That's a lot of time, right? And now we still have a lot more work to do on this, and we still have to, figure out with more confidence that certain parts of this are viable, but this is actually like really, really promising, right? So this is something that we're really, really excited about. So what we found is that like the dumbest method you could possibly think of solving this problem actually is pretty effective. Little tiny fast IP block lists that are updating all the time, that are big, right? Big block lists. They work a lot better than we thought they were going to work. So it's really exciting. So anyways, to stay in front of the next log4j, there's really not a lot we can do about the vulnerabilities themselves, but we can actually help this problem by centralizing information and as best we can, or at least giving people a window into everything that's going on with opportunistic exploitation, and providing like ready-to-use block lists that are updating all the time, right? So that's what we built, and that's what we're releasing right now at this exact moment for free for everybody. And so basically, this is a free product that we're releasing called GrayNoise Community Trends. And so what this is this. You can go to this right now if you're on your laptop. You just go to GrayNoise, and you can click on a tag, and everything works. And you go here, and basically, this one is for log4j, but you go here, you can see a time series of how much exploitation of a vulnerability is happening at scale on the internet right now. You can see a timeline, et cetera. And you can see over here on the right side, we've got a button that says block at firewall, right? So you click that button, and then it pops out this thing that has a block list URL it's a custom block list, basically, right? So you grab this URL, and that URL at the end of that is a UID, right? And you basically punch that firewall list into that URL, into your Palo Alto, into your Cisco ASA, into your whatever, so the next time this happens, you're going to be able to really quickly go from, oh my God, everything is bad, everything's on fire, and you grab this, and then this is me just curling it. It's just an IP list, right, of everyone who's exploiting that vulnerability, et cetera. And so this is free. This is available right now. And our hope is that basically the next time things get bad, people are going to be able to really easily go from learning what they need to learn and blocking the host that they need to block. We're not going to make you safe forever, but we are going to make you safe for long enough that hopefully you can do something about it, right? You can actually you can apply the patch, you can put the rules in your CDN or in your WAF or however you're doing that. And so hopefully this is something that really provides some value back to the security community, and we're really excited to announce it. We've put a lot of work into kind of getting it together, and so I'm really happy and excited about it. So anyways, in conclusion here, internet exploitation, internet-wide exploitation, mass scanning the internet, people trying to exploit as many different devices on the internet as humanly possible, it is quantifiably getting worse. I really hate to tell you that. It is just getting worse. It's going to continue to get worse, and that's just how it's going to be. A really big network of sensors, kind of like GrayNoise, is something that is actually effective at buying people a little bit of time to solve the problem. And running a really big network of sensors is a huge pain in the ass. There are so many problems, but I wanted to cover as many of those as you can. And if you do it, you'll kind of understand some of those problems as well. You probably want to use ours, but that's fine. And instead of just hoping that the vulnerability doesn't happen, it will, right? So let's just get prepared for what we can do the next time this happens, right? So that things aren't as bad. And that's it. So I just want to say thank you guys so much for having me.